welcome to a video going over data analysis for our second lab. Now within this second lab, you're going to notice a pretty similar format. You're going to be making different columns in Table 1 and Table 3 for your different groups of data. You're going to be calculating the average, the standard deviation range, the standard deviation range, and the SD divided by the range. And then in Table 2, you're going to be deleting data, which should update your groups or your computations for data table 3. Now when I go into the data table, here is our data. Officially after this morning's experiment, we have 73 sets of data. Pretty good. Now within this experiment, you're going to be dividing your data into different groups based on temperature. Now there are a couple ways that you can do this. The first might be looking at a slice of cake in the X and Y axis and saying, oh, they look pretty similar. So for example, if I look between 0 and 20, I see 7 or 8 temperature dots that are all pretty consistent and similar. So that might be my first temperature group. So in order to do the data analysis, you're first going to divide your groups into different ones. And you might, over time, manipulate those groups. But each group will be copy and pasted their equation slopes in this third chart over here called the t-test format. Now, I'm going to just for right now show you the difference between two different groups of data. So my first group is going to be 0 to 20, so I'm going to highlight columns 2 all the way down to column 11. And I'm going to Control C, and I'm going to Control V. And what you should know is right off the bat, you're going to have in columns below the average, standard deviation, the max, and the min for the standard deviation range, the range of the total data, and also your SD divided by your range. That's going to be really useful for you to just plug and chug into this data table right here. Now, I'm going to be doing a thing called a t-test in just a minute, and to do that, I need to have my second group of data right here. So I'm going to, right now, delete this, go back here, and maybe I decide my next group of data that might be different from each other is 10 to or 20 to 30. So I'm going to highlight the data. 20. Oop. I accidentally should have done just a 10. I'm going to go all the way down to 30. And I think that is, oops, I need to look at this. Okay, 25. Nope. There we go. I'm going to highlight this data, copy and paste, Control V. I'm going to delete this data. And notice we have average, we have standard deviation, we have range, max and min, we have our range, and we have our SD range. Now, part of this assignment that you should be doing during these group formations is determining whether some of this data is good or bad. So I'm going to practice that right now. Once I've built all of my groups, I might go back and delete some of the data that doesn't quite fit. So if I'm looking through this data of 16.133 and 19.894 clearly don't matter or don't match, same with 17.73, and that is maybe going to give me a slightly more accurate representation of what's going on between 20 and 30. So in terms of data that you can delete and record in your second data table, it can be data where the slopes feel abnormally high compared to the rest of the group at that same temperature. And you also can use R-squared, and RISME also has benchmarks for whether this data is good or bad. So if I look here, 17.73, which I just deleted from my group, has a RISME of 556. That data seems pretty far-fetched. So to summarize so far, you're going to be making groups of data. You're going to be copying and pasting those groups of data slopes into this column right here. into t-test format, which will automatically give you your average, standard deviation range, and SD range. And then you're going to go back and delete that data and record that in your second table, which will give you updated computations. The last thing we have to talk about is table 4, which is new. Again, that's going to be where you record your group, 0 to 20, your average, your SD range, and then finally your t-test. And the t-test is a statistical test looking at whether or not two averages are likely different from each other. Not the whole group of data, but rather just the average. And what we're going to be looking at is this fancy little calculation down right here, which is going to give us the probability of the data being similar to each other in terms of their average. And I'm going to format this as a percent. And what this is telling me is 0.00139, or as a percent, 4.14%, which is pretty low, is the likelihood of these two data points being identical. We're going to be using a cutoff of 0.05 as our benchmark for whether or not we think that two things are different. So this is telling me, because it's below 0.05, and I can write this down here right after I'm finished with this, that it's likely that these two averages are significantly different from each other. Now note that my SD range is still a lot bigger for my second group, which is why I have overlap, but it might mean that I have two different things to discuss with whether I accept or reject that these two groups are different. I might be saying that I accept that the two groups are different based on their averages, but maybe because of that change in temperature, the variation in my second group would be a lot bigger. And again, when I look at this data, I would be 0 to 20, 20 to 30, right here be discussing whether or not I accept 0 and 20 are different from each other. Over here, I would be talking about 20 and 30 being different to the next group in my data tables. I hope this has been useful. Again, we are going to be talking about 0.05 as our cutoff. If it's below that, the two averages are different. See me for questions, and I hope you have a good day.